Hi, I'm GUO CHENG GUANG, 30 years old, secondary one for NS High School. In this part of here, we are going on with our limits, alright? And we have started limits some time before. So right now we're still revising what we have learned before, alright? So to help us revise what we have learned before, we're going to use these two examples. And let me just tell you, so far what we have revised is direct substitution and factorization. So we are only going to use these two methods. We are not going to use any other methods, alright? So let's take a look at the first example over here. So limit x approaches to 2. Then I have x to the power 4, subtract x cubed plus x squared minus 3x minus 6, and over x to the power 4 minus 3x cubed minus x squared plus 9x minus 6. Right, first of all, we have to check which form is this. Is this determinable or is it indeterminable? So here you're going 2 to the power of 4 would be 16. So 16 minus 8, you get 8. And 8 plus 4, 12. And 12 minus 6 minus 6, well that's 0 on the numerator. Then on the denominator, 2 to the power of 4 is 16. So 16 subtract 24, which will give you negative 8. And then negative 12. And negative 12 minus 6 would be negative 18. And here is plus 18. And so this is in the form of 0 over 0, right? So this is in the form of 0 over 0, so we cannot use direct substitution right now. And wait, because this is 0 over 0, and you're using x, you start in 2. So that means you could take out x minus 2, since 2 is causing this 0, right? Isn't that right? Because here 0 and x you start with 2. So definitely there must be x minus 2. So for this part, all that we're going to have would be to take out x minus 2 on both sides, right? Since these are causing the 0. So in this part, we will be needing to use long division. So this part first divided by x minus 2. So suppose you match these terms together. And here, first part is x to the power of 4, then you subtract 2x cubed. And then subtract this entire part, so we get x cubed plus x squared. Then plus x squared. And so here you have 3x squared minus 3x. They have to plus 3x. And so at this part it is 3x squared subtract 6x. And here you're going to get 3x minus 6. And you can see that this is fully divisible. Right, so we will need to use this part above, right? But wait, this part, can we continue to simplify it? If you have realized it, good for you. So this is the first two terms. And this is the last two terms. Then you can combine them together and it will become this part. And thus, here you get x squared plus 3 and x plus 1. Right, so right now here we're just fully factorizing it. And then same thing goes to the denominator, so I'll just erase this part and I'll replace it for the denominator, right? Alright, so at the denominator, x to the power 4, subtract 3x cubed, subtract x squared plus 9x minus 6. And this part divided by x minus 2. So x minus 2 for the first one, of course, x cubed. And then x to the power 4 minus 2x cubed. And for this part, you have negative x cubed. Then you subtract x squared, and then you subtract x squared over here. And thus you get negative x cubed, then plus 2x squared. Alright, and for this part it is negative 3x squared plus 9x. They have to subtract 3x. And here we're going to have 3x minus 6. And thus just add 3, and here it will be fully divided. And so from this part, at the same time, we're also going to fully factorize it. Alright, just now we did first two terms and last two terms, right? Could we scale across? Yes, we can. So for the first and the third term, so we're going to have x and then x squared minus 3. And then for the second term and the last term, which will give you negative x squared minus 3. And thus you have x minus 1, x squared minus 3. So when you write it over here, we're just going to write x squared minus 3, then x minus 1. So these two, we're just going to simplify them. And the remaining parts will not give any zeros anymore. So let's take a look at what they will give. So 2 squared, 4 minus 3, this part is a 1. And then 2 minus 1 is another 1. So this denominator has now become 1. And for this part, 4 plus 3, 7. 2 plus 1 is 3. And so you have to find out 2 times 7, which is already 21. And so the answer for the first example is 21. Alright? So this is the first example over here. Just get a quick look at all of these. Alright, I'll be moving on to the second example. Okay, so I'm just going to write it down here that this is equal to 21. And now for the second example that we have here, which is limits z approaches 1 plus I. And beware, I over here is the imaginary number, which is square root negative 1. And from this part, 1 plus I minus z over square root 1 plus I minus square root z. So at this part, you could choose to use, some of you might just directly think a minus b and here a squared minus b squared. You just directly times a plus b on both sides. But are we going to do that here? No, that's called rationalization. But right now, we're only going to use direct substitution and factorization. But actually, factorization and rationalization over here, the usage is pretty much the same. So let me just show you factorization. So you're just taking this as a squared minus b squared. Just factorize it into a minus b and a plus b. So with this part. Then these two parts that make it 0 over 0, and by the way this is 0 over 0. So these two parts, we have to cancel them out. And thus this will give you, well, you could just directly sub it in right now, which is a direct substitution. And this will give you 2 square root 1 plus I. Can we finish here? Unless given in the question that you can leave it in terms of square root, whatever. Otherwise, we can't just stop over here. We can't put I inside this square root. And we can't put I inside the square root, so we have to think of something else to change this part, right? So to change this problem, 1 plus I. We have to think in terms of the Euler formula. And using the Euler's formula, we have to be aware of what this will become. And by the way, Euler's formula you will need to use. Well, let me just tell you right now here, I'm just going to use a positive form, right? But if you want to work the full part ahead, yes, you can go ahead. So let me just briefly tell you how this thing works. So e to the power of this entire thing, right? Which you are using e to the power of I theta being equal to cosine theta plus I sine theta. So if you are quick, yes, you can work this out pretty fast. Since from this part, but wait, e to the power of square root 2 over 2. Square root 2 over 2, you put it inside. Nah. Pi over 4i, that's more like it. So you're putting pi over 4 inside here. Cosine pi over 4 is the same as sine pi over 4, which is square root 2 over 2. And since some of you can calculate it very fast, square root 2 over 2 times square root 2, it will just give you 1. And thus, when this part you calculate it, it will give you 1 plus I. Right? So that's how you can find it really fast. So the next part of here, square root, that means you have to make it to the power of half. So this part you have 2 to the power of 1 over 4. And together this 2 is 2 to the power of 5 over 4. Then behind here, e to the power of pi over 8i. Then you might think, are we finished yet? Let me just tell you, no, we're not going to leave this I inside this E. If you leave it like this, you may get a misconception that everything here is now imaginary. But wait, not exactly. Look at this Euler's formula. We do have a real part, right? So, we will need to separate the imaginary part and the real part. So first of all, just simply use Euler's formula. And then you have cosine pi over 8. Then you add 2 to the power of 5 over 4. Then I sine pi over 8. You think, are we done yet? Because we've already separated imaginary part, real part. But no, we can still continue to find what's this value of 4 cosine and what's this value for sine. So that's the next part that we're going to continue with. This part for you may seem tricky, right? Since we've only thought of, or you might have only remembered for like pi over 4, pi over 3, pi over 2, all those. But you didn't go and remember for pi over 8. But let me just tell you, you don't need to remember this, alright? So let me just show you, if you see this thing, might seem extremely familiar. So cosine 2 theta, this is equal to cosine square theta, subtract sine square theta. Does this look familiar to you? If it doesn't look familiar, let me just show you the 2 other forms that you could write it in. And maybe you'll recognize some of them. So I've written these 3 forms over here. Well, if you have recognized it, good for you. But this is the double angle formula for cosine. And now we want to get for cosine and sine. So if you want to work this out, since you might have forgotten another formula, you can just easily work it out. So wait, let me just write this as so this is what you get for cosine theta. Well, if you have realized just now, I'm not going to put cosine 2 theta plus 1. Well, let me show you why. In this form, you can actually remember it easier. For cosine, it's plus. For sine, it's minus. So if you in a test and it doesn't require the steps, then you can directly use this formula faster. Alright? So cosine this part. So cosine this one. Then we're going to times 2, which will give pi over 4 for each one of them. And since you're going to get pi over 4, isn't that great? Pi over 4 is the same for both, and in fact it is square root 2 over 2. So square root 2 over 2, then you can just use 2 plus square root 2 over 4. This part, you could just use it, right? Yeah, you can. And then for the other part, which will be 2 to the power of 5 over 4, then square root, but now it's minus, so 2 minus square root 2 over 4i. And now just to continue simplifying it. So from these two parts, so it gets divided by 2 to the power of half. So divided by 2 to the power of half, or is it? No, divided by 2, exactly 2. So you're going to get an extra 2 to the power of 1 over 4. And here is the 2 to the power of 1 over 4. So you could just directly use square root 2 square root plus 2. And then here you have the plus, well, pretty much the same thing happens here, which is square root 2 root 2. Now it's subtract 2, and here I. So actually, from this part you might not think that you could find it until this simple, right? But I'm just telling you, yes, it is possible. So I hope that you're clear of this so far, and you know how to use direct substitution and factorization in these two examples. Alright, so I'm just going to end this lesson here, and thank you for your watching.